Hello everyone, this is Aditya and today we're going to complete quadratic equation in one go. So let's start with the lecture, but before that please do like, share, subscribe my channel and please support this video. Now let's start with the lecture. So someone said me to make the videos in English, that is in the combination of English and Hindi. So what I'm thinking is that I will make two playlists for this series and I will make one in Hindi and one in English, right? But not right now because there's lack of time right now. So what I'm planning to do, first of all, I will complete this series in English, then I will start in Hindi, right? Okay. So now let's start with this lecture. So let's understand the basics of quadratic equations first. So we all know that any polynomial written like this, ax square plus bx plus c equal to fx, right? It is called a quadratic polynomial, right? So this is called a quadratic polynomial, right? Okay. Now when you set fx is equal to 0, then you get ax square plus bx plus c is equal to 0. And this is called quadratic equation, right? And since its degree is 2, right? Hence, it can be factorized like a times x minus alpha 1 into x minus alpha 2 is equal to 0. Hence, it has two roots, right? Now, I did not say that two real roots or two complex roots. I just said two roots. So, roots can be complex also, complex number or an real number, right? Of course, a real number is also complex number, right? Okay. So, this is how you factorize it. Let's multiply this. So, when you multiply it, you get a x square minus alpha plus this quantity into x plus alpha 1 alpha 2, right, is equal to 0. Correct or not? Did you understand? X minus alpha 1 multiplied by x minus alpha 2, right? So x into x is x square and this you can multiply it easily, right? Okay. But this expression was equal to this expression, right? Which implies that a times x square minus alpha 1 plus alpha 2 times x plus alpha 1 into alpha 2 is equal to ax square plus bx plus c, correct? Okay, let's multiply a over here, so we will get ax square minus a times alpha 1 plus alpha 2. You are understanding alpha 1 and alpha 2 are the roots of this equation, right? Why? Because if you substitute alpha 1 as x as alpha 1, you will get this expression as 0, correct? And if you substitute x as alpha 2, you will again get this expression as 0. And any other value except alpha 1 and alpha 2 won't satisfy this equation, right? Okay. Plus a times alpha 1 into alpha 2 is equal to ax square plus bx plus c, right? Okay. Now notice that we are going to compare the coefficients, right? So with ax square we have, with x square we have a, right? Okay, both sides. Okay, so it is fine. Sorry, here it will be x also, right? Now notice the coefficient of x, it is equal to negative a into alpha 1 plus alpha 2 and over it is b, right? So it is equal to b. Hence, sum of roots is equal to negative b by a, right? So alpha 1 plus alpha 2 is equal to negative b by a. That is the sum of roots is equal to negative the coefficient of x divided by the coefficient of x square, correct? Okay. Similarly, what is the coefficient in this case? That is the constant value. So a times alpha 1 into alpha 2 is equal to c, correct? Hence, alpha 1 into alpha 2 is equal to c upon a, right? So the product of roots is equal to c upon a, correct? Understood? Okay. So the sum of roots is equal to negative the coefficient of x divided the coefficient of x square, and alpha 1 multiplied by alpha 2, that is the product of roots, is equal to the constant value divided by the coefficient of x square, correct? Okay. So this was the basics which you need to know, and there's one more thing which we need to discuss. Let's discuss that also. Okay. So suppose this is a quadratic equation, right? And we need to find the roots of this equation. So how we'll find? So there's a formula x is equal to negative b plus minus root b square minus 4ac by 2a, right? Do you know how we get this formula, right? Do you know it? If you don't know, then you should check out its proof also, right? You can do it yourself. I can tell the method. You have to just make a perfect square in this case. I can tell this much, okay? You have to create a perfect square and then you can get this expression, right? I won't tell its proof right now. You have to solve it yourself. If you can't do it, then please do let me know in the comment section. I'll make a video on it, okay? So this is the value of roots. So let's assume it has the root alpha and beta, correct? Let's assume instead of alpha 1 and alpha 2, I assume alpha and beta, right? So let's recap. Alpha plus beta is equal to negative b by a. Alpha into beta is equal to c upon a, correct? Now what is the value of alpha minus beta mod, right? What is its value? Well, you can use this expression to find it, right? Suppose alpha is equal to negative b minus negative b square minus 4ac divided by 2a, and let's assume beta is equal to negative b plus root b square minus 4ac divided by 2a. Let's subtract them. We get alpha minus beta is equal to negative 2 root b square minus 4ac by 2a, correct? Did you understood? We just subtracted it. So when you subtract this and this will get cancelled, and minus minus, it will become twice the negative value of this quantity, right? So alpha minus beta is equal to negative root b square minus 4ac divided by a. So we take the mod. So we get root b square minus 4ac divided by mod a, right? So this is equal to root b square minus 4ac divided by mod a, right? These are some of the basic formulae which you should remember, right? And of course I told the proof of each and everything, so you can easily derive it also if you want to derive it, if you forget it basically, right? So this is the basic of quadratic equation you must be knowing from your previous classes, right? And of course I recapped also, right? So now let's start something called, you must have guessed it, Newton's identity. Let's start with that. Newton's identity. Let's discuss this also. So suppose your quadratic equation is ax square plus bx plus c is equal to 0, right? Okay. And suppose it has roots alpha and beta, correct? Okay. Now assume you are asked to find this value, alpha to the power n plus beta to the power n, right? You are asked this value. How will you find it? And suppose this is called Sn, right? Let's assume it, where of course n belongs to natural number, correct? Okay. So how will you solve it? Well, what you're going to do is that just substitute it over here. A Sn plus b Sn minus 1 plus c Sn minus 2 is equal to 0, right? Okay, so what is Sn minus 2? It is alpha to the power n minus 2 plus beta to the power n minus 2. And similarly for n minus 1, it will be n minus 1, n minus 1, correct? Okay, but how do we get this formula? And is there any generalization of this formula? There is one generalization. Instead of this, you can also use p into alpha to the power n plus minus q beta to the power n is equal to Sn, right? So it holds true for this expression also. In this also you can say a Sn plus b Sn minus 1 plus c Sn minus 2 is equal to 0, right? So how good it will be if you know its proof also. So let's discuss its proof also. Suppose this is our quadratic equation, ax square plus bx plus c is equal to 0, okay? Correct? Okay, and suppose it has roots alpha and beta, right? Okay. So let's substitute, and we are asked that Sn is equal to, suppose, now let's prove it for general case so that you can easily prove it for other cases, right? Suppose p into alpha to the power n plus minus q into beta to the power n, right? Okay. So how will we do it? Well, it seems too complex, but it is very easy. Let's see. So ax square plus bx plus c is equal to 0, correct? So let's substitute alpha over here. So we get a alpha square plus b alpha plus c is equal to 0, correct? Okay. So now let's multiply both sides by alpha to the power n minus 2. So a alpha square plus b alpha plus c is equal to 0. Hence we get a alpha to the power n plus b alpha to the power n minus 1 plus c alpha to the power n minus 2 is equal to 0. Just see it once. Is it correct or not? alpha to the power n minus 2 multiplied by alpha square will become alpha to the power n. Alpha to the power n minus 2 multiplied by alpha will become alpha to the power n minus 1, and alpha minus alpha to the power n minus 2 multiplied by 1 will become alpha to the power n minus 2, right? Okay. Now notice we need p over here also, right? So let's multiply both sides by p. So a p alpha to the power n plus b p alpha to the power n minus 1 plus c p alpha to the power n minus 2 is equal to 0, right? Okay, right, simple. Okay, now similarly let's substitute beta over here. So what we get beta alpha, I mean a beta square plus b beta plus c is equal to 0, correct? Okay, now again multiply by beta to the power n minus 2, similarly you did over here, right? So you get a beta to the power n plus b beta to the power n minus 1 plus c beta n minus 2 is equal to 0. Now let's multiply by q, right? Okay, so a q beta to the power n plus b q beta to the power n minus 1 plus c q beta to the power n minus 2 is equal to 0, right? Okay, now let's write them together. So we have a p alpha to the power n minus, I mean n, plus b p alpha to the power n minus 1 plus c p alpha to the power n minus 2 is equal to 0, and a q beta to the power n plus b q beta to the power n minus 1 plus c q beta to the power n minus 2 is equal to 0. Let's apply this operator plus minus, right? Let's apply it. We can do it like that. Okay, so it will become a into p alpha to the power n plus minus beta, I mean q beta to the power n plus b times, correct, q beta to the power n minus 1 plus c times p alpha n minus 2 plus minus q times beta to the power n minus 2 is equal to 0, right? And what is it? It is equal to asn, this is sn minus 1, and this is csn minus 2 is equal to 0. And this is what we needed to prove, right? Hence this is called Newton's identity, right? So this is Newton's identity, and it is very simple to solve, right? If you know the concept that how you prove it. And now if I give you any degree polynomial, you can easily prove Newton's identity in that case, right? So now it has become very much clear to you, right? So let's start the next topic. So if you want, we can do a simple problem also. Suppose x square minus 5x plus 4 is equal to 0, and it has roots alpha and beta, right? Okay, of course you can find roots in this case easily, but still we will apply Newton's identity. So we are asked to find alpha to the power 4 plus beta to the power 4, in this case s4, right? So let's apply it over here. So we get s4 minus 5 s3 plus 4 s2 is equal to 0, correct? But we see that we don't know how to find s3, right? We can find s2 by some means, but it will be difficult to find s3. So let's apply Newton's identity for s3. So s3 minus 5s2 plus 4s1 is equal to 0, correct? So from this now we can easily find s3, correct? So s3 is equal to 5s2 minus 4s1, right? Now alpha plus beta is equal to negative b by a. So negative of negative 5 will become 5, and alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. You know x plus y whole square is equal to x square plus y square plus 2xy. So x square plus y square is equal to x plus y whole square minus 2xy, correct? Okay. So it is equal to 5 square minus 2 times alpha beta. It is 4 upon 1. So it will become this quantity. So we get 25 minus 8, which is equal to what? 17. So we get 5 times 17 minus 4 times 5, which is equal to 85 minus 20, which is equal to 65 s3, right? So let's substitute it over here. So we get s4 is equal to 5s3 minus 4s2. So we get 5 times 65 minus 4 times 17. So we get 5 2 carry, so we get 325 minus this quantity 68. So we get over here 325, 68. We get 2, 1 carry, and we get 5 over here, 7, right? So we get 257 as the answer, right? Correct. And of course, if you see any calculation error, then please do let me know in the comment section, because I don't know that if I make any calculation error, because I'm just trying to tell you the concepts. I'm not focusing on the calculation that much. That is your work, of course, for calculation problem solving. So I'm trying to just tell you all the concepts. Okay. So I'm really sorry if I make any calculation mistake in this procedure, right? Okay. So let's see the next topic. So suppose if you have a equation like this, an xn plus b, an minus 1 xn minus 1 and so on till ax plus a1 x1, that is simply that a0 is equal to 0, right? A general polynomial equation, right? Okay. And suppose it has roots alpha 1, alpha 2 and so on till alpha n, correct? So what is the sum of roots? Plus alpha n is equal to negative of an, right? Of course, you can prove this also using that method only which I told you, but that's not needed. If you know that method, you can easily think and solve this, right? So basically the coefficient of x to the power n minus 1 divided by the coefficient of x to the power n, right? Okay. Now suppose if you take 2 at a time, that is alpha 1 alpha 2 plus alpha 1 alpha 3 and so on till all the pairs which are possible, it will be equal to an minus 2 divided by an, right? We are just moving one term ahead, okay? And notice that we have coefficient of 2 over here, so we don't have a negative sign. You can remember like this, right? Okay. So basically, and if you take 3 at a time, alpha 1, alpha 2, alpha 3 and so on, you get negative an minus 3 divided by an, right? Okay. Correct? Okay. So we get, suppose we multiply all the roots, we get till alpha n, we get a0 divided by an negative 1 raised to the power n, correct? Okay. So this is a general way to write the coefficients and roots, right? Okay. It is a basic relation between them, okay? So let's take a cubic equation to solve it, to understand it. Plus cx plus d is equal to 0, correct? Okay. So suppose it has roots alpha, beta and gamma. So alpha plus gamma is equal to negative b by a, right? Just try to understand, right? Alpha beta plus beta gamma plus alpha gamma is equal to c upon a, correct? 2 at a time. And alpha beta gamma is equal to what? Is equal to negative d by a, right? In this case, right? Negative plus negative, like this, the alternate pattern is going, right? Understood? Okay. Now I can make it like this also. Suppose I make it like let's change the coefficients. I make it as x to the power 4. Let's do this one, c d e, and suppose it has roots alpha beta and delta, right? Alpha beta gamma and delta, correct? So sum of roots alpha beta gamma plus delta is equal to negative b by a. Okay. Now take 2 at a time. So alpha beta plus alpha gamma plus alpha delta, right? How many pairs will be there? If you study PNC, you will understand that there will be 6 possible pairs in this case, right? Plus beta gamma plus beta delta plus gamma delta is equal to c upon a. Okay, but how did I made this pair? Well, it is simple. I had alpha, beta, gamma and delta, right? So first I took first root and I multiplied it with rest, right? So I got alpha beta plus alpha gamma plus alpha delta, right? Then I went to the second root and then I thought that I should multiply it with alpha. No, I will not multiply. Why? Because I have already multiplied it. So I will go to the next term. It will be gamma and delta. So I get beta gamma plus beta delta, correct? Now I move to the next one, it is gamma. So gamma multiplied by the next root, it will be gamma delta. Of course, there is no other root. When I go to delta, I see that there is no next root in this case. So this is the only product, right? Taken two at a time, right? Okay. Okay, so let's take three at a time. Alpha, beta, gamma plus alpha, beta, delta. Similarly over here also, alpha, beta, gamma and delta. So first I took alpha, beta and gamma, then I took alpha, beta, then delta, right? So alpha, beta, gamma, alpha, beta, delta, right? Plus, then I went to the next one, I took beta, gamma, delta, right? I took this one, okay? So I got beta, gamma and delta, right? This one, okay, correct? Fine, okay. So we get beta, gamma, gamma and delta, right? But notice that we need one more pair also. We need alpha, delta and gamma. So we will get over here alpha, gamma and delta plus beta, gamma, delta, right? So in one case we will neglect beta also, right? Okay. So there here it will be four possible ways only. Why? When you study PNC, you will understand it. Okay. So it is equal to negative d by a, correct? Okay. Yeah. And then let's take all four roots alpha, beta, gamma, delta. We get e upon a, right? So this is the basic generalized expression between the roots and the coefficient, and these are some of the examples, right, for third and fourth degree polynomial, right? And of course it is applicable for second degree, that is quadratic also, right? So this is how you check it, right? This is how you prove the relation between roots and coefficients. Let's move to the next topic, right? So let's study nature of root, right? Nature of root, right? Okay. So how do we study it? Let's see. We know that suppose these are quadratic equation, right? So when you solve it, you get negative b plus minus root b square minus 4ac by 2a, correct? So what is that quantity which is determining the nature of root? And of course we assume that a, b, c belongs to real number, right? Correct? Okay. So of course this quantity is the only thing which is inside square root. So of course if it will be less than 0, then it will be equal to some complex number, right? And if it will be 0, then it will give 0, and if it is non-zero, it will give something else, right? Non-zero positive value, right? So of course this is the reason. So using this expression we can check the nature of root, that whether it is real or imaginary. So this expression b square minus 4ac, we have a special name that we call discriminant, right? Okay. So if b square minus 4ac is greater than 0, then we say that the roots are real and distinct, correct? Correct? Okay. And suppose if b square minus 4ac is equal to 0, we say that roots are real and equal, right? Okay, correct. And if b square minus 4ac is less than 0, we say that the roots are complex or imaginary, we can say imaginary, right? Correct? Okay. So in this also we have something else to discuss, like suppose when you solve it, you get the root as negative 1 plus root 3. This is our first root, suppose. Then the second root will be the conjugate, this negative, okay? If here we have an irrational term, okay? Understood? Okay. Correct? Okay. And suppose if here we get x1 is equal to 1 plus I, then what will the second root? It will be equal to x2 is equal to 1 minus I. Why? Because it always exists in pair, right? You know it. Minus b plus minus root b square minus 4ac by 2a, right? So of course we have a plus minus sign, right? Here also plus minus sign, right? Correct? Okay. And if we have a real root, then we can factorize it x minus alpha into x minus alpha multiplied by a. So of course it has also two roots, but they both are equal to each other, right? Okay. So this was the basics of nature of roots, right? And of course this is the basic theory which you should know. And of course you can solve it. It is the basic result which you should know, right? Okay, do you know how to form quadratic equation from the given root? Suppose I give the root as 1 plus root 3. I just gave one root and I said to form quadratic equation. So how will you form it? Well, actually I've given two roots over here. Since we know that it always exists in pair, so the second root will be 1 minus root 3. Correct? Correct? Yeah. So we know that quadratic polynomial, that is quadratic equation, can be written as a times x minus alpha 1 into x minus alpha 2, right, is equal to 0. We can write it like this, okay, where alpha 1 and alpha 2 are the roots. Correct? Okay. So now notice that when you multiply it, you get x square minus alpha 1 plus alpha 2 x plus alpha 1 into alpha 2 is equal to 0. It is that case only which we did before, right? But now we are checking how to create the equation. Okay. So a times x square. So what is the root? Alpha 1 and alpha 2. So basically a quadratic polynomial, a quadratic equation basically can be written as a times x square, a times x square, or you can in fact remove this a also since it is equal to 0, right? So instead we can say a times, we can basically say this expression, right? These are quadratic polynomial, right? Quadratic equation I mean, okay? So we can remove a over here. So we get x square minus sum of roots multiplied by x plus product of roots, right, is equal to 0, right? So what is sum of roots? Sum of roots is equal to 1 plus root 3 plus 1 minus root 3 is equal to 2 minus 2x plus what is the product? 1 plus root 3 and 1 minus root 3. It is equal to 1 minus 3, which is equal to negative 2. Correct? Correct. So it becomes negative 2 is equal to 0, right? Okay. So this is our quadratic equation, right? And if you solve it, you will get this answer, right? Okay. So this is how you create quadratic equations, right? If you want, I can solve it also. Correct? Okay. Simple. So let's erase this and now let's discuss transformation of equation a bit, right? So suppose if you have a quadratic equation ax square plus bx plus c is equal to 0 and it has a root alpha and it has a root beta, right? I mean alpha beta are the roots. And you are asked to form a quadratic equation whose roots are 1 upon alpha and 1 upon beta. So basically in such cases we use transformation of equation. Transformation of equation, right? So in this we use transformation of equation, right? Okay. So basically if you see that both the roots are applied the same function or applied the same operation, then we come to know that we have to do transformation of equation. What do I mean is that suppose you're given alpha and beta as the roots. So over here you took the reciprocal of alpha, you took the reciprocal of beta. So basically you did the same operation on both the roots, right, to get the new equation. So in such cases what you do is that you substitute x is equal to 1 upon alpha. So you say that alpha is equal to 1 upon x, right? Basically it is inverse function which we are doing, right? That is the basic idea. Okay, that is the case. Okay, hence we get, then you substitute this value of alpha over here. So a times 1 upon x square plus b into 1 upon x plus c is equal to 0. Hence you get a plus bx plus c x square is equal to 0 is the answer, right? Okay. Now there were two methods to solve this. Either you could have used 1 upon alpha plus 1 upon beta, which is equal to beta plus alpha by alpha beta, which is equal to what? Which is equal to negative b by a, negative b by a into c by a. We get negative b by c, and 1 upon alpha beta is equal to 1 upon what? C by a. I mean a by c, right? Okay. Hence, x square minus b by c, x plus a by c is equal to 0. So cx square plus bx plus a is equal to 0, right? Correct. Okay. So that is the idea. Suppose instead of 1 upon alpha, I would have said 1 upon alpha minus 1 and 1 upon beta minus 1, right? Means I applied the same function in both the cases, same operation in both the roots, right? So again, put 1 upon alpha minus 1 as x, so you get 1 upon x is equal to alpha minus 1, so you get alpha is equal to 1 upon x plus 1. So just substitute it in the given equation, right? 1 upon x plus 1 whole square plus b into 1 upon x plus 1 plus c is equal to 0, right? This is how you solve such kind of equations, right? Such kind of problems. So it depends. If it is easier, you apply this. If this is easier, then apply this, right? Whatever you think is simple for you, just apply that, right? Okay. And yeah, that property, that transformation of equation is valid for any degree polynomial, right? You should remember that one. Okay. So let's see now common roots. Common roots. So suppose if you are given a quadratic equation a1x square plus b1x plus c is equal to 0 and a2x square plus b2x plus c is equal to 0, c1 and c2, right? And you are said that one of the roots is common this. So what is the condition for that? Okay, so if I say you won't need condition all the time, right? It will be like 90-95% you don't need the condition. For example, if I say ax square plus bx plus c is equal to 0 and cx square plus bx plus c is equal to plus a is equal to 0, and you said that there's a root common in this. So in this you are asked that find a relation between the coefficients. So if you apply the condition which I am going to tell, you will feel like that it is going too much lengthy, right? But if you see this equation, you will understand clearly that x is equal to 1 is a clear solution in this case, right? Okay. And if you can't observe it also, just assume that, let's assume that alpha is a common root to both of them, right? So we get a alpha square plus b alpha plus c is equal to 0. Now let me tell you a method that will help you always. Whenever you see any equation and you are asked that there is a root common, okay, just take that root, you assume that root as alpha and substitute in both the equations and then solve for that root only, right? Okay. So basically if you find any root in quadratic polynomial, that is quadratic equation, just substitute back in the equation and you will see that maximum of the problem is solved, right? So basically I am saying that whenever you get the root, you solve the equation, you get the root, just substitute it back into the quadratic equation and it is 100% sure that then the problem will be solved, right? Are you understanding or not? Let me explain it. So here it becomes c alpha square plus b alpha plus a is equal to 0. Let's subtract it. We get a minus c alpha square plus c minus a is equal to 0. Hence we get alpha square into a minus c is equal to, sorry, this is a minus c, and of course a is not equal to c. I should have written that condition, but that is true. So alpha square is equal to 1, right? We got this. So we get a is equal to, alpha is equal to plus minus 1, right? Now which we have to take and which we have to neglect. If we take 1, we get a plus b plus c is equal to 0 and c plus b plus a is equal to 0. So that is correct. So of course we have to neglect the negative one. Of course, two roots can't be common, right? Because we have said in the condition that only one root is common, right? That is why. So alpha is equal to plus 1 is the solution. So when you got this, what do you have to do? I said you, whenever you get the value of any root, just substitute it back into any of the equation. And it's not just a case for common root, it is for anything, right? Anything related to quadratic equation. whenever you get the value of root, just substitute back it into the equation. You will see that most of the problem is solved, right? Just substitute it back. What you get? A plus B plus C is equal to 0, and that is the relation between coefficients. That their sum is equal to 0. Correct? Simple. Okay. So either you do by observation, or either you just apply this method, right? You just assume a equation, a root, and then you substitute it, then subtract, and then solve. That is the basic method. Okay, right? So let's erase this, and let me tell you the condition also. Okay, so the condition is a1 c2 minus a2 c1 square is equal to b1 c2 minus b2 c1 into a1 b2 minus a2 b1, right? Okay, I'm telling how I got this expression. Okay, so a1 x square plus b1 x plus c1 and a2 x square plus b2 x plus c2 is equal to 0 is equal to 0. So basically for this term, just forget the middle term and just cross multiply a1 and c2, a1 and c2, then subtract a2 and c1, right? Correct? Okay. Then for this term, just take this one, right? So b1 c2, b1 c2 minus b2 c1, right? And over here, a1 b2 minus a2 b1. Simple. Understood? It is just cross multiplication. Okay, right? Now it is the condition of what? It is the condition for at least one root common. Okay, sorry, this is common, right? So it is not telling that one root is common, but it is telling that at least one root is common if this is satisfied, right? So now it can write two roots are common or one root is common. Of course, a quadratic equation has two roots only. Okay, so this is to check for one or more roots common condition, right? Or if you have to check for whether two roots are common, I mean both the roots are common, then a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. Basically both the equations will be same in that case. Suppose x square plus 2x plus 3 is equal to 0 and 2x square plus 4x plus 6 is equal to 0. Of course this both seem to be distinct, but they are not distinct. Why? Because when you divide it by 2, you will see that they both are same equations. So it is taking that only, that we were initially having here 2, here 4, here 6. So 1 by 2 is equal to 2 by 4 is equal to 3 by 6. Correct? All have the value of 1 by 2. Correct? Okay. So this was about common roots, right? Simple. So now let's see the graph of quadratic polynomial, right? Let's see it. Graph of quadratic polynomial, right? Let's see it. Okay. So how the graph of a quadratic polynomial look? Let's see it. So fx is equal to ax square plus bx plus c, right? So how do we plot it? Well, that is something related to conic sections which you will study later. So just now remember that it looks like this graph. Okay, now this is your x-axis, right? Now it can be drawn in three ways. So let's see that. If discriminant is greater than 0, if discriminant is equal to 0, if discriminant is less than 0, right? And let's assume if a is greater than 0, a is greater than 0, and a is greater than 0, right? In all three cases. So it looks like this. Here it looks like this. Here it looks like this, right? Okay. Why is it the case? Because we know that if discriminant is greater than 0, then we get two real distinct roots, right? So it is represented that only alpha 1 and alpha 2, right? This is the x-axis, right? Okay. And if d is equal to 0, then we get that both the roots are equal and real, right? So this is the case, this x-axis, right? Okay. Now if discriminant is less than 0, we don't get any real root, right? Hence it won't cut the x-axis anywhere, right? So, and since a is greater than 0, so the curve will be upward facing parabola, right? It is called a parabola, right? Okay. Now what if I say d greater than 0 and d equal to 0 and d less than 0 and a is less than 0, a less than 0, a less than 0, right? So it will be like this, it will look like this, and it will look like this, right? Correct? Okay. Again, similar condition, just a is negative, so that is the parabola is now downward facing parabola, right? Similar case in this also, you know that discriminant less than 0, so you won't get any real value, so that is why it goes like this, and it goes till infinity, right? Infinity, it is going till negative infinity, it is going till positive infinity, right? Fine. Okay, so let's erase this. Okay, so we got this polynomial, this graph I mean, for parabola, right? So this is called the vertex, right? This is the vertex. So what is the coordinate of vertex? It is negative b by 2a comma negative d by 4a. How do we get it? So in this there are two methods. Either you apply differentiation, right? You know it, or second you apply quadratic, right? I mean perfect square, right? So I will be telling you using differentiation, right? Because second method is like perfect square method, which you can do because that is in the derivation of quadratic equation only, right? That is why. So let's see it. So suppose fx is equal to ax square plus bx plus c, correct? Okay. So let's find f dash of x. It is equal to 2ax plus b, and let's calculate f double dash of x. F double dash of x, it is equal to 2a, right? Okay. Now set it equal to 0. We get x is equal to negative b by 2a, right? Okay. So this is the critical point over here, right? Okay. Now notice that if you substitute back it in this equation, you will get f of negative b by 2a, which is equal to a into b square by 4a square plus b into negative b by 2a plus c, right? So we get b square by 4a minus b square by 2a plus c, correct? We will get this, right? So we get when you multiply it, you will get negative b square by 4a plus c, so you get 4ac minus b square by 4a, which is equal to negative b square minus 4ac by 4a, correct? So we get negative d by 4a, correct? Okay, so this is the y component, right? And this is the x component, right? Okay, so depending upon the value of a, if a is greater than 0, then this is the point of minima, and if a is less than 0, then it should be the point of maxima, which we have proved also. The graph looks like this if a is negative, right? So this is the vertex, negative b by 2a comma negative d by 4a, right? So graphs are really important, so that is why I'm taking lots of time in this. Okay, so this is the case. Okay, this is simple. Now what if I ask you, when can a quadratic polynomial be always positive? Let's see it. But before that, I need to ask one thing. Suppose this is the quadratic equation, x square minus 3x, or this quantity, sorry, quadratic polynomial, this is the polynomial. So in this case, what will be the vertex? It will be negative of the quantity, this quantity, so it will become 3 by 2 comma b square, that is 9 minus 8, it will become 1 upon 4, negative 1 upon 4, correct? Correct or not? See, negative of negative 3 by 2a, 2a is equal to 1, so we get 3 by 1, so 3 by 2, and here we get b square minus 4ac, so we get by 4a, of course, so we get b square, that is 9 minus 8 by 4 times 1, which is equal to 1 by 4, and of course there's a negative sign, so we get this. Okay, correct. Okay, so suppose if I ask you that what is the range in domain, suppose 0 comma 5, so what is its range? Let's calculate that. Okay, so it is a very simple procedure, right? Okay, of course discriminant was greater than 0, so it will have x-axis at 2 points, right? But of course we don't need it right now. Okay, and since a is positive, so it is a upward facing parabola, correct? Here its vertex is like this, negative 1 by 4, so 0 lies somewhere over here, right? This is 0, 0 comma 2, correct? And 5 lies somewhere here. It was 5 comma 25 minus 15. 25 minus 15 is equal to 10. 25 minus 15 is equal to 10. 10 plus 2 is 12, right? 12, correct? Okay. Now what is its range? Well, range is from negative 1 by 4. What is the least value? Least value is at the minima only, right? So it is from negative 1 by 4 to 12, right? The maximum value. Hence, range is from negative 1 by 4 to 12, correct? This is the range. Okay. Now, suppose if I ask the range in domain 3 comma 5, right? Let's take simple. So 3 will lie somewhere over here, right? 3 is lying over here. So corresponding 3, what is the value of y? 9 minus 9. 3 square minus 3 into 3, 0. 3 comma 2. So in that case, vertex is not coming in the domain, right? So it means that in that case, we will assume this only. In this, it is an increasing function, of course. So range in that case will become 2 to 5, correct? Yeah. Sorry, 2 to 12. This value, right? So this is how you check for the range if you are given a domain, right? So it is a trickier part. So you have to check for the vertex also while checking for range, right? Okay. Yeah. So let's erase this. Yeah. So I was asking that when can this quadratic polynomial be always greater than 0 for all x belonging to real number? This means for all. This means belongs to this real number, right? So we know that we had a graph like this, if you remember, for a greater than 0 and d less than 0, correct? So of course, if d is less than 0, then we won't get any real value in this case. So of course, it won't cut the x-axis at any point, right? So it means that either it should go upward or it should go downward, right? So of course, if a is greater than 0, then it will be an upward facing parabola. And if a is less than 0 and d is less than 0, then it will look like this, correct? So if a is greater than 0 and d is less than 0, then in this case we will get that this polynomial ax square plus bx plus c is always greater than 0 for all x belonging to real number, right? As you can see from the graph also, right? Because it is going from what is the range? What is the value of this function? Fx belongs to negative d by 4a to infinity, correct? Since the value of vertex is negative b by 2a to 2 minus d by 4a, right? Correct? Okay. This is the value of vertex, the coordinates of vertex, right? So it is going from negative d by 4a to infinity, right? Positive infinity. And over here, it's also negative b by 2a comma negative d by 4a, correct? Okay. But in this case, it is always negative. Ax square plus bx plus c is always less than for all x belonging to real number, right? That is the difference. And in this case, what is the value of fx? Fx belongs to negative infinity to negative d by 4a, right? Correct? It is included in this. So in this, we are getting a maxima, and in this case, we are getting a minima, because f double dash x was equal to what? We had calculated it was equal to 2a. So if we assume a is greater than 0, so f double dash x will be greater than 0. So if f double dash x is greater than 0, so we get a minima. If f double dash x is less than 0, we get a minima. We get a maxima, right? Okay. So that is why that is the case, and it is a very famous thing which you should remember because it is generally asked in exams. Okay. So it is really important. Okay. So let's study the last topic of this chapter, location of roots, right? Now it is something which is logical, right? But still, I think I should discuss it a bit, right? So suppose the first case, if suppose there is a k, suppose like this, right? A k lies between two roots, right? Then in that case, a, suppose the equation is x square plus bx plus c is equal to 0, right? Is equal to fx, right? So basically we want a k such that it lies between alpha and beta, right? Okay. And this is a polynomial, so the condition for this is a into f of k should be less than 0, correct? Okay, why? Because f at k will be negative and it is an upward facing parabola over here. So a is positive, so a times a is positive and this negative, so positive into negative will become negative. And if it is a downward facing parabola, then in that case it will look like this. So f of k will be positive but a will be negative, so a of f of k will be less than again 0, right? Correct. Okay, now let's assume the second case. Suppose you want the cases that it should be at the left of alpha and beta. So in that case you will have a f of k greater than 0, correct? And d greater than equal to 0. Why? Because of course there should exist a root, so that this exists, right? Of course if there's no root, then how can you check it? Because it can satisfy this also. Suppose it is like this, k is lying over here, so in that case also a f of k is greater than 0, but d is not greater than 0 in this. In that case there exists no root, right? That's why. And k must be less than minus b by 2a in this case, right? This is the condition. So basically if you want to throw a number left of both the roots, then this is the condition, correct? Okay, third one, suppose if you want to throw it on the right side, then also the same condition, a f of k greater than 0 and d greater than equal to 0 and k greater than negative b by 2a, right? Here we will have negative b by 2a less than k, right? Why? Because of course here it is the vertex and it is ahead, the k is ahead of vertex, right? That is why. And you know that why I took a into f of k, because f of k will lie somewhere over here, right? So f of k is basically positive in this case and a is also positive, so it will be always positive. And if it is a downward facing parabola, f of k will be negative and a will also be negative, right? So this is the case. Okay, and suppose if you have to just throw this k on the either side of alpha beta, or I mean on the either side basically, so it means that either you want to throw it over here or over here, right? It is not defined. So in that case there's only two conditions, that a f of k greater than 0 and d greater than 0, right? There's no need to involve b in this, the vertex in this. Why? Because you don't know the position of k. It can be over here also, it can be over here also, right? Okay, now let's see a fifth condition also, this one, that suppose you want a root to be between two numbers. Suppose this is k1, this is k2, and you want alpha to lie between these two. So what is the condition for this? Well, f of k is positive in this and f of k2 is less than 0, hence their product will be always less than 0, correct? Correct or not? Correct. Okay, so from this you will solve it, and whatever value you get in this, you have to check. Suppose from this you get a solution like, suppose a belongs to negative infinity to 10 closed, I mean open, union 15 to infinity, right? Suppose you get such kind of solution. So in this you have to check for boundary condition also, that whether at a is equal to 10 and a is equal to 15, whether then also it is satisfying or not. So you have to check for boundary condition also, right? So it is a nice concept. I think that we should discuss a question on it, but we will not discuss in this video, we will discuss in some other video. But for now you should know that whatever roots you get, whatever answer you get from this, right, you have to check for boundary condition, that is at 10 and 15, right? Okay, that is the case over here, right? Okay, so there's a chance that you have to include 10 also, there's a chance in this, or you have to include 15 also, or you have to include both of them, right? Okay, depending upon the conditions, right, you will give an interval, right? So with this we come to an end of this one shot. So I hope so that you enjoyed this lecture. If you did, then please do like, share, subscribe my channel, and we support this video. Bye bye, take care, and all the best.